Hi, my name is Matt Zeiler. I'm the founder and CEO of Clarifai. Today, we're going to walk you through how to label your data for artificial intelligence up to 100 times faster by leveraging artificial intelligence to automate the data labeling process to ultimately speed up model development. This is leveraging the Clarifai platform, which is built on top of the NVIDIA technology stack. The overall agenda is going to walk you through how to get up and running with data labeling very quickly, leveraging pre-trained models. But then we're going to talk about how to customize models to label the specific things that you care about. Then we're going to talk about auto-annotation, which is where the game-changing of 100x speed up over human labeling comes into play by automatically annotating data using artificial intelligence. And finally, we're going to wrap up with how you can perform active learning directly in the platform because we have all of the tools for the entire AI lifecycle in the Clarifai platform. To give you a little bit of background about Clarifai before we begin, I founded the company back in 2013. We have office locations around New York City, Washington, D.C., San Francisco, and Tallinn, Estonia. And our research team has now grown to amass over 140,000 citations in various scientific fields. This has led to a lot of great investments from Menlo Ventures, Union Square Ventures, Lux Capital, and many others, raising over $41 million to date in Clarifai. And we kicked off the company by winning the top 5 places in ImageNet 2013, marking us as the world's best in image recognition. That title has carried with us through many different awards. More recently, a notable award was Forrester naming us a leader in the computer vision platform space. We were the only startup given that title. I want to walk you through now what Clarifai has become over the years. And essentially, it's become a complete ecosystem around artificial intelligence. If you look at the middle of the screen where it talks about the platform tools, this is all of the tools that are built into the Clarifai platform that really give you all of the abilities to operate the full AI lifecycle within a single platform. We focus our products around unstructured data, images, video, text, and audio. So when you input that data, you can perform a lot of the data labeling, search, training, prediction, and workflow tools in the same platform around that unstructured data. The first of those tools that you typically encounter is Scribe, which is built from the ground up to label your data at scale, leveraging artificial intelligence in as many ways as possible, which you'll see a lot about today in today's talk. Now, Scribe is usable as a product itself or as what we call label force, where we take care of the data labeling process for you, leveraging our human workforces to label and provide high quality training data. Spacetime allows you to manage that data as it scales. Search is a crucial component to that. So you can slice and dice your data into training and evaluation sets, share saved searches with collaborators, and even power new applications with things like visual search to find products or video streams that look similar to a query image. Enlight allows you to train on top of your data, and we support a variety of different training types, which you'll see today. We also support that as a service, so we can leverage our research team, which is world-class at solving your problems for you. Armada lets you take those trained models and run them at production scale. It automatically scales traffic based on the amount of requests each model gets. We also have a human-in-the-loop version of this, so humans can verify predictions to guarantee high levels of accuracy, even if your model is not at that level. Mesh allows you to connect multiple AI models and functional models together into one computational graph. This allows you to do more complex processing in the same platform that you build your AI. And these mesh workflows are really crucial to a lot of the things you'll see today, like automating annotations. Flare is the only thing in this row that is not actually in the cloud. It's at the edge. So you can do processing of models you train in the cloud on streams of data at the edge instead of shifting that data around. This allows you to process in lower latency environments, low power environments, and even disconnected from the internet. When you are connected, you can sync models from the cloud down to the edge and data back from the edge to the cloud to improve future versions of your model. As you can see in the bottom, the AI fabric connects all this together. It allows you to run our platform on any of the public clouds, your own on-premise environments, even air-gapped environments where there's no connection to the internet. And we have integrations with many popular tools and an ever-growing set of these, and a growing community who is labeling data and connecting things in our knowledge graph so that you benefit. On top, you're seeing a huge amount of the use cases that our customers are powering using the Clarifai platform. You can see we organize content by metadata generation, tagging it. We can perform visual search and media similarities, even recommend products, like take a picture of an item and find it on a retailer's site. A lot of intelligence and security applications are powered by the Clarifai platform in both commercial and public sector sides of our business. We moderate out content that's unwanted, like nudity, drugs, weapons. We can do deep media analysis, like segmenting out videos, add cutscenes, recommending better ads to match the videos. In the physical world, we can get into quality control on the manufacturing line, or recognizing before a machine fails, if it's going to fail, like cracks and defects or sound quality changes. We can also understand long documents and extract different textual fields and numeric fields from them automatically in the visual space and process them with natural language processing. And finally, we have a whole suite of face recognition products for a variety of different use cases, leveraging your face. So all of this makes up the Clarifai ecosystem. And you can see this is a combination of many of the tools that you need to automate data labeling. So let's take a look at what that looks like. We see this as a huge problem. When you're thinking about building high quality models, data is often the bottleneck, taking up as much as 60 to 80% of the time spent on the model development in the data labeling process. So when we approached data labeling with the launch described last year, we wanted to automate as much of it as possible using artificial intelligence, which is our core competency. And so that's what we did. We have a suite of pre-trained models to get you up and running in your domain very quickly. And that suite grows over and over, so the chances of you having a model that fits your use case grows over time. We allow you to quickly customize these models to recognize things that you care about. So it really tunes to your domain and then can be used to automatically label the data for you. So you cut out the amount of human work dramatically. So we're going to walk you through each of these steps today. So with these pre-trained models, you really get the immediate results. You get up and running literally within minutes. And then with customized models, you can quickly learn to recognize what you care about. And these models can be used to assist the humans doing the manual work so that they're not just manually drawing boxes or manually typing in the concept names or categorizing things. They're more verifying what the AI is already telling them. That's useful when the human's in the loop. Auto-annotation takes that to a whole new level. It's when humans are taken out of the loop and we automate the process of annotation at scale. So when new data is uploaded into an application, we can automatically trust the predictions that are high confidence and then send the ones that are low confidence to humans to verify. And finally, because you can label data, search over it, train, run at production scale, all in the same platform, you can complete the active learning cycle, which is really important for production quality models. You want your models not to just be trained once and thrown on a shelf and forgot about. You want them to be continually improving over time through the process of active learning and improving based on the data that you're actually predicting on. You can do all of that completely in the Clarifai platform. So let's take a look at these pre-trained models and how they help you get up and running with projects quickly. We've been training a variety of models for common use cases that our customers are solving today. These start with apparel as an example in the retail industry, recognizing different types of clothing. And they range all the way to different face recognition models like celebrity demographics, moderation models for nudity, drugs, weapons, etc. Even embedding models for machine learning teams to get high-level representations out of the inputs and be able to do whatever machine learning they want on top of them, whether that's their own training or visual search type of applications. We believe we're one of the most accommodating platforms for machine learning experts out there. One of the key components of the platform that's really important when you're thinking about data labeling and model building is search. And we think we're the only platform that combines all these things in one place. We allow you to search over your data by the human annotations, by AI predictions, and by a variety of other means like visual similarity search, textual similarity search, geolocation, even metadata. So you can tag your content to organize it in whatever arbitrary ways you can come up with. These searches aren't just automatic at the time of query, but they could be saved so that you can share them with collaborators and collaborate on building great AI. And those saved searches can be used to designate what is the subset of data that you want to label. So you can manage huge data sets across an organization very easily. You can also carve out the training sets and evaluation sets separately using powerful search queries. And this gives you the flexibility to manage your data at scale. Let's take a look at some of the additional powerful applications with search in the process of labeling itself. Because the data gets indexed by a base workflow in an application, in this case we have the face workflow configured in this application. So every time we uploaded these pictures, they actually get indexed by that workflow. Now we're just going to create a few example names of concepts that we can label on these images. So these are just arbitrary names we're making up. We don't really know the people in these pictures, but we're using this as an example. Now what we just did by hitting that search query was leverage the fact that we've already indexed this data for search. And the query itself is the picture in the query bar. So it's doing a visual similarity search of all the cropped out face regions. You can see those dotted bounding boxes, which allowed us to find more pictures of the same guy. And now we labeled those 7 selected pictures as Joe. So that's one example of being able to find a person. Now let's see who else is visible in this data set. We're going to search for the lady, and of course we find a few examples of her. We can do bulk selection to grab those first 4, which are her, and we're gonna assign her the name of Sarah. So now we've labeled a few more examples of a different concept. So you can see the power of search in play here, combined with bulk labeling. You can iterate, find more content before you've even trained a model, before you've labeled any data. We didn't need to know that this was Joe or Sarah or Ali. We can search by similarity. And that's a really powerful concept that speeds up the labeling process. And we haven't customized any models yet. This is using pre-trained face recognition workflow that only is detecting the different faces with the bounding boxes you see, and then embedding them so that you can actually do visual similarity search amongst all the detected faces without having to train any models. And once you have a few of those different concepts labeled, then you can go on and create custom models around them. Now, another important aspect of our platform is it's organized in a knowledge graph under the hood. And this is really valuable because as you use these pre-trained models, they're built in a vocabulary owned by Clarifai. So these are the way that we think about the world, which might be the same as the way you think about the world or might be different. You might spell things differently. You might use unique identifiers that are unique to your business. You might use different languages even. So the knowledge graph allows you to relate all these different things that might be talking about the same thing as synonyms in the world. And so you can create those synonym relationships and then leverage that to map concepts between one vocabulary and another. Another use of the knowledge graph is representing hierarchical relationships. So you can say that a dog is a type of animal and a Saint Bernard is a type of dog, as an example. And this types of data management allows you to wrangle your data and leverage the pre-trained models or models from other users in your application to automate the annotation process. So let's take a look at one example way of leveraging the knowledge graph. And this is what we like to call proposers. So in this example, we're looking at kind of vacation pictures, and we're gonna create a few made up names of backpack brands, let's say. And you can see there's a few pictures here of backpacks from this hiking trip. And we're gonna leverage one of our pre-trained models that can detect people, a variety of objects, including backpacks. And that's our general detection model. So this is already trained, highly accurate detection model for your use cases. Now, that's great because it recognizes some off-the-shelf things, but if you wanted to recognize things like those brands of backpacks that are unique to your application, you can relate them through the knowledge graph. So here in the proposer UI, you see the prediction of backpack, and we're going to relate it to one of the concepts that we created, Maya. And we're going to tell it that Maya is a child of backpack. So it's a hyponym, is the official terminology we use here. And so now that we've created that relationship, in the proposer UI, we're going to show Maya every time that a backpack is recognized. So as you're flipping through images, this quickly surfaces the concepts that could be important to you to allow you to verify that this is a Maya backpack. So this helps speed up the labeling process using artificial intelligence. And finally, once you're in this process of training models or even using our pre-trained models, you don't want to think about the inference process. You want to be using those models for your application or using it to label more data. And so we built Armada from the ground up last year to make the inference process transparent to the user. There's not even a deployment button in our platform. And the way it works is leveraging NVIDIA Triton under the hood, which is a great toolkit for allowing you to run TensorFlow, PyTorch, Onyx, or even Python arbitrary backends and run multiple backends on the same GPU. However, we made it work across a fleet of nodes of GPU servers. So you can have models that automatically get provisioned. If there's no replica of the model and some inbound requests come in for that model, it will actually be automatically loaded. If more requests go to that model, more replicas will be loaded up. If less requests, less replicas, all the way down to 0 replicas. So you don't have to ever think about managing models again. And this is huge to the productivity of data science and developer teams. They no longer have to throw their models that they just trained over the fence to a DevOps team or an infrastructure team to deploy them. That team doesn't have to do any bookkeeping. They don't have to have any involvement with the AI teams anymore. And you don't have to think about how much these models are going to cost you. You can have literally thousands or millions of models deployed, and they can run efficiently as you can pack GPU memory onto GPUs, and will automatically be managed for you. So we're very happy to announce our model last year and have it be a key pillar of our overall platform. Now let's take a look at what it means to label with custom models. So these are models trained to recognize what you care about. And we support a variety of different ways of training in our platform. The first we'll cover is quick train. And this allows you to transfer learn on top of any of those pre-trained models you just saw in the previous section. And we do this about 100 times faster than we've ever seen, and with less data than anybody else is being able to leverage. And so we can literally learn from a single example, and it gets smarter, obviously, the more data you throw at it, but you start getting benefits from one example. So that allows you to quickly train a model with one example, use that to surface more data in search. You don't have to re-index your data every time you train. We've filed patents around this technology, and find data that represents that concept you just learned about to be able to label more data, train the model, and repeat. This is a really important process in the active learning flow. Let's take a look at quickly training a new model. So here we're back in Portal, and we're going to create a model. We call this a context-based classifier because it's learning based on the context of a pre-trained model. And in this case, we're going to train it to recognize the different types of Teslas. So here we created a quick model and added the two concepts of a Model S and a Model X. As you can see here, we version every model. So every time you click train, it will learn and create a new hash, just like Git. We version them so you can run one model version in production while you are building the next. And so you can see how quickly it learned how to recognize those concepts, just a few seconds, and we even evaluated it just as quickly. So we got some accuracy measures out of the model. Now we're going to take a few more examples and upload it into the application so that we can see how the model performs and label additional data. So here we're in data mode, where you can upload in bulk from your file system, and you can also attach metadata. So this is important for those safe searches, as I was mentioning earlier. You can attach things like, I want this to be the training split or the test split in the metadata, and then filter that out by a search query and use that for your training and evaluation. All right, now that we've uploaded the data, let's take a look at how this model performs. So here we're going to look at annotations on this current image. There's none yet. We're going to take a look at the model predictions of that brand new trained classifier. So here it's saying with high confidence that this is a model X, which is actually incorrect. So we want to actually create a labeling task to get additional data because we've only trained it on a handful of examples. So here we're showing scribe, where we're going to label all of the inputs in this app. We're going to use all the concepts. I'm just going to use myself. I'm logged in as Jeff here. And I'm going to assign all of the inputs in across all of the workers, in this case just me, and then I'm going to enable AI assistance. So I have that custom trained model that I'm going to use to assist me in the labeling process. So here we're taking a look at scribe, and we're going to go through input by input and see how that model performs, controlling thresholds above which we're going to trust the prediction of the model and automatically recommend that to be a green check, so saying that this is a model X. And then below a bottom threshold, we can say this is not a model X, and so forth. So this is a process of AI assistance. As you can see, it sped me up in the labeling process, automating a lot of the work for me. As you start accumulating additional data, you can dive into deep training. So in contrast to quick training, which quickly learns based on the context of a new model, deep training learns from scratch. It's only using the pixels of your data or the text snippets or audio signals and the output labels that you desire, like concepts or bounding boxes, to be able to learn what you care about. So this allows you to learn anything. It doesn't depend on the suite of pre-trained models that we have available in our platform. It can also push the performance very high because with a lot of data, it can really extract what you mean out of your data set. And we provide a bunch of templates to help you get up and running with state-of-the-art algorithms to be able to train your models very quickly. So you have control over the hyperparameters, but we have a lot of recommendations in there. So even if you're not a research scientist, you can click a few buttons and train a high accuracy model automatically. This does take a little bit longer than quick training because it is learning from scratch. It has to go through many iterations over your data to learn what you care about. But the trade-off is you can get higher accuracy and learn domains that are brand new. And this is some findings we've actually looked at. You can get annotations that in an example where we're recognizing a trailer truck, you might need only 439 examples to train a transfer learned classifier with quick train, and it can take under a minute to learn on those 400 plus examples. However, with deep training, we used almost 6,000 examples, and that took almost an hour, but the accuracy was quite a bit better. We saw that not only the accuracy was better, but inference time is faster. Because with transfer learning, you have to process multiple different models in a workflow to be able to recognize what you care about. Whereas with a deep trained model, it can be processed in a single model. And so we see that the average inference latency of a quickly trained classifier for this type of use case, where we're detecting many different vehicles, cropping out each vehicle, and then running each of those vehicles through another classifier, takes upwards of 140 milliseconds, whereas a single model that's deeply trained can take as little as 415 milliseconds in its median latency. And so you can sustain a much higher throughput on the same single GPU hardware. So there's benefits of deep training beyond just accuracy in the fact that you can actually run inference more quickly. The next section we're going to cover auto-annotation. Now this is the process of automating the annotation process using artificial intelligence so that humans do a fraction of the work. And we're literally seeing over 100x improvement in both time and cost. And we use this ourselves to automate the labeling process for some of those pre-trained models you saw. And these are real ROI that we're seeing in both the amount of time it takes to label high quality data sets, and ultimately that leads to the amount of dollars it costs to label them. And so the idea is very simple. Trust your AI models when they're very confident, label the data automatically with that prediction that they make, and send the rest of the data to humans to do the labeling. Now this can be done with a bunch of scripts and a bunch of different vendors, but it's really important that within Clarifai, this is all within the same platform. So you can do all these complex workflows, configure them directly, run them in the platform that you're going to actually label that data, search over that data, train the models, and then run those production models without any DevOps needs. So all of that can work seamlessly in the same platform. And that's really important because those production models that are the end result are going to be running on streams of data that you can pipe into the auto-annotation process to continually improve your artificial intelligence models. So this is really exciting. Now let's take you through a look at one of these workflows. So your inputs at the top, these can be any input added to your app, which could be manually added, like you've seen in a few of the demos today, or through collection of prediction streams, which we support natively in our platform. So let's say you have a production model running on the real world data that you care about. You can collect that in and it adds it to your input just as if you manually did it using a collector. And then the auto annotation workflow runs after that regardless of how you added data to the platform. So in this case, we're going to run a public model over that. And some of the public models might be used for search, and they might embed things for visual search. They might cluster things together. But then there's models that make predictions. So that's the branch you're seeing in the middle of the screen. Now, because the Clarifai application, it has its own vocabulary for common things, we want to map those using our knowledge graph into the vocabulary of your app. So it can recognize after that point the things that you care about. So then you can branch off and do a variety of different things. You might have in this workflow a visual detector to recognize people and track them over time. And then high confidence regions, say greater than 0.8, can then be treated as successful annotations of persons. Then the middle confidence ones, the ones that are not really low, things that are 0 are very unlikely to be a person. So you want to kind of ignore those. And then the things that are above 0.3 but below 0.8, those are things that you probably want to send to a human to verify whether it's a person or not. And over time, those thresholds can be adjusted in this workflow because your model is going to get more and more confident of what is a person and what's not a person. Another branch in green here is a classification branch. Again, you can do arbitrarily complex mesh workflows in our platform, so you can actually do this all in the same input to classify things. So in the classifier, you might just have concepts that are very confident above 0.8 be automatically treated as annotations. And then again, mid-range confidences you want to send to a human to review. So all of that is in a single auto annotation workflow. Let's take a look at what that looks like in practice. So we're going to create an application, and in this application we're going to show you how to make an auto annotation workflow and automatically annotate your data. So an application is essentially a project, so we just created that, and here we're going to create a few concepts that we want to treat as our vocabulary for this auto annotation task. Now we're going to assemble those building blocks into a single workflow to do our auto annotation. Now, the first model that we're going to run over the inputs that are coming in, the images or videos that get sent into this app, is the vehicle detector. This is going to go from the pixels and return bounding boxes that are detected vehicles. Now, after that vehicle detector is added to my application, I'm going to add the concept mapper so that it'll map into my vocabulary. Then I'm going to threshold those vehicles in my vocabulary, and then I'm going to write them to the database. And you can see that was the sequence of building blocks in that auto annotation workflow. Now I'm going to change the base workflow of my app so that whenever data is added into this app, it's going to run that workflow that we just created rather than the general model. And you can see we haven't actually created or uploaded any data up until this point. So now we're going to go ahead and start uploading some pictures of vehicles. And this will run through that vehicle detector, keep the high confidence ones, and then automatically annotate them for us. So we didn't do any training yet. We haven't done any manual labeling. We're going to see what this looks like when we upload a few examples into this app to automate the annotation process. So in this case, we picked one example just to give you an idea of how this looks, but this would equally apply to a huge amount of data being uploaded. and there's no human in the loop during this upload process. So this is how you get the scale out of the auto annotation workflows. In this case, we uploaded a video, so now we can take a look at that annotation throughout the entire video. Here we can look at the workflow itself. This is a handy tool built into Portal to let you verify on your inputs what these workflows are actually producing. And you can see the things that are actually detected as vehicles get mapped into my vocabulary, and they get passed through the thresholding. And then finally, the ones that appear here in the annotation writer are the things that were confident enough to be written to the database. So all of those bounding boxes were automatically annotated. No drawing from a human, no typing in vehicle, no manual work whatsoever. We automatically labeled every vehicle that I can see in this picture. And this was over a whole video, actually, not just this one frame. So the whole video is automatically annotated as well with high quality predictions. And so this is highlighting a lot of different things. The speed up is tremendous. You can see easily for this one video, we're already past 100 times faster than if you were to draw those bounding boxes yourself. And because we're leveraging pre-trained models like our vehicle detector, which is trained on millions and millions of examples, the quality of the labels are at least as good as a human would be able to do, which you could see there as we played the video. The final section we want to run you through is active learning. So this is the idea that you now have a stream of data that you want to collect from in your production environment. You have a great quality model, it's running, and it's processing the real world data. That's the most valuable data to use to improve future versions of that model. So with auto annotation, you can collect it into an app and then run it through auto annotation workflows to threshold detections or classifications above or below a certain threshold. In this final section of the talk, we're going to run through active learning in the Clarifai platform. This is the process of leveraging a production quality model on a stream of real world data to improve future versions of that model or other models. So once you're running in production, you have the data that is the most important to improve future versions of the model, the data that your application actually cares about. So you can use collectors in our platform to collect that stream of data into an application. As it's added to the application, the auto annotation workflows can be used just like in the previous section to determine the predictions to trust or those predictions to send to humans. And the high confidence are typically the ones you're going to trust. The low confidence are the ones that you need humans to review. Those get done through either manual work or automated work and create a huge amount of annotations that can be used to train the next version of the model. And because that model is quickly trained using quick training or deep training and then automatically deployed, that can improve the collection process and the auto annotation process by updating the workflow to the latest version to improve the quality of automatic annotations and reduce the amount of human annotations needed while producing a higher quality production AI model in the process that is predicting over your application's data. So let's take a look at what that looks like. So you might have a huge batch of unlabeled data on the far left. It could be your stream of data that you're actually using in production for your real application. And the initial iterations of your model might start with this unlabeled data and do a little bit of manual work in Scribe to label it according to what you care to predict. Then you can quickly train a new model in Enlight. And because that training process is so quick, using quick train, you can get up and running with a model that you can get the sense of how good the task is, how difficult it is, how feasible it is, and how much data you're going to need to make a really high quality model. Even with those initial models, you can start running them in production. And because you don't have to even press a deployment button, you get a faster time to market. You can get your AI models out there into your application, providing value to your users. And that's all powered by Armada. Now that you have those models out in production, they can start producing predictions, and then you can decide using auto annotation if those high confident predictions are good enough. You can send them right into the training process to make future versions of the model even more accurate. If the low confidence ones need humans, you can send those to Scribe automatically. They'll show up as work to do for the worker. You don't have to resend things or email out anything. This is all fully automated in our platform. That just gives you a quick tight loop around the active learning flow so that your production quality model starts very quickly and gets better every day after that. Let's take a look at what this looks like. We're going to show you here the notion of collectors. So let's say you have a production quality model in your flow of your application and you want to collect data from it. So that's the idea behind collectors. So we're going to create a collector here, and we're going to make it just sample all of the data that it gets as input. So all of the predictions here, we just had a very simple workflow set up already called sample all. And it's going to sample 100% of the inputs that the model predicts on into the application. And then you can combine that with any workflow attached to the application to automatically annotate your data. So that's how simple it is to create a collector. You could see it used a input key because a collector is almost like an agent that works outside of our API to make calls on your behalf. So it's identical to if you add that data yourself to the application versus being collected automatically through a collector. Another important aspect that we didn't cover thus far, but is so important for active learning, is evaluation and managing all these custom models. So as you keep training and using those models to label more data, to train future versions of the model, and keep doing this tight loop, it's very important that you have version control. So we built that from the ground up to be very similar to Git. So everything is a unique hash when you train a model. So you can go compare versions of the models. And very importantly, you can evaluate each of those versions to see how they're performing on your data. So let's take a look at what that looks like. So in this case, we have a model that we're about to train. There's no model version trained yet. You can see that first version is the initial kind of commit, if you will. When we hit train, it learned very quickly from these 117 inputs, and it shows that there is a trained model version. Now we have two versions. We can evaluate that trained version where it's going to do cross-validation to see some statistics about your data and how the quality of that model is. Now let's take a look at those evaluation metrics to give you a sense of what we can see. This is back to that Tesla Model X versus Model S example. Here we have two categories, the Model X and the Model S. And you can see in the evaluation summary table, you get a ROCOC score per concept, common evaluation metrics like true and false positives, false negatives, precision and recall, etc. You also get to see a confusion matrix, so you can see how confusing these two concepts are. In reality, they are somewhat confusing for new users of Teslas. And below that, you can see precision recall curves and ROCOC curves. So you can actually see as you tune thresholds, which dynamically change everything you see in this evaluation page based on the threshold at the top, you can see how your model performs. You can also see where things are confused, some examples on the right-hand side, and more version details on the top right. Now let's take a look at training another model version and seeing how important the evaluation process is. So we quickly trained a new Tesla classifier, created a new model version. This one's trained on some additional data, 142 inputs. And when we evaluate, you can see the overall estimate evaluation metric, the ROCOC score, improved. So this is a quick signal that you can look at across all your versions of how good this model is performing overall. And that allows you to complete the active learning cycle. So to recap, we have shown you 4 different ways of leveraging artificial intelligence to automate the data labeling process to speed up your model development in AI. You can do that through pre-trained models to get quick results, literally within seconds of signing up. Then you can customize models to assist you in the labeling process and search in very powerful ways over your data set that is ever growing. Auto-annotation is game changer. It gets humans to do a fraction of the work, and you can scale up kind of infinitely based on artificial intelligence using its high confidence predictions to automatically annotate data for you. And finally, being all of these things in one platform, you can do the full active learning process. When you're running production models, collecting data automatically into your app, automatically annotating that data, searching over data to craft training sets, training it in our platform, evaluating all of the model versions you've trained, and then without even hitting a button, you have an updated high quality production model to use for your application. Thank you very much for your time. Happy to take any questions over email.